Good evening, all. So, well, I think we can start the session. So, yeah, others can join as we move on. And the objective of this today's session is actually to give you a briefing. So, I think all of you have taken part today here with the objective of joining this challenge, which is the competition that is focusing on applied robotics. So my objective here today is to give an overall briefing of the competition. So right now we have certain participants who are registered. I'm not sure the ones who are here are the ones who are registered for the event and actually are looking forward to get some idea of how to proceed, or ones who are totally new. However, I will just overall cover everything that's related to the competition, starting from the registration and what sort of things we're expecting, and also some general overview of what sort of robotics that we're actually focusing in this competition, right? Okay, so I will share my screen. Okay, so actually, this is actually a new challenge that we started this year. It's the first time that we're doing this, and this is the IEEE Sri Lanka Type Robotics Challenge. So today's discussion actually has mainly four objectives. So we want to discuss what the challenge is all about, and then I'll actually talk about the key robotics categories that we'll be focusing on under this challenge, and I'll try to give a briefing on each of these category, and then I will also brief about the competition stages and the process of the competition, and also how to participate, and some tips on succeeding in this competition. So we are part of the IEEE Challenge Sphere. So as you all already know, IEEE Challenge Sphere is probably you might not know. So it's actually the umbrella that all the challenges is organized by the IEEE Sri Lanka section falls under. So currently we have 7 challenges under the IEEE Challenge Sphere. So we have the Artificial Intelligence Challenge, Circuit Challenge, Arduino Challenge, Robotics Challenge, Chip Challenge, Communication Challenge, and the Healthcare Innovation Challenge. So there are altogether 7 challenges, and out of the 7 challenges, we are focusing on the Robotics Challenge. Actually, this is the Applied Robotics Challenge, not the Robotics Challenge, because not to get confused with the SLRC organized by the Industry Motor, we are actually going under the name of Applied Robotics Challenge. So you probably might wonder why we thought of focusing on another robotics competition when there's already so many robotics competitions in the country. So you probably might be aware of several competitions, and you probably might have taken part in some of the competitions as well. So we actually thought of doing something new because most of the robotics challenges that's there in the country currently. I have been part of some of these competitions as an organizer, as a competitor, as a judge. So, most of these competitions, they are focused on completing a task. So you are being given a task at the beginning, whether it's, navigating through something, completing a maze, a combat challenge, or completing a particular task. So there is a fixed task, and it's narrowed down into just completing that task. So the thing with those challenges is it's mostly testing a certain skill set of yours, but they are not oriented on something open-ended, something actually that we can get out of the all towards the society. It's actually measuring a particular competitive parameter. But in our case, we thought of going a step further and actually implementing something, a challenge that can actually benefit the overall community. So it is an open-ended thing. It's not going to be something narrowed down like a maze solving problem, but it's going to be something that is focused on solving some societal challenge, right? So, and since we are going to talk about, this robotics in general, I actually want to define what a robot is in the beginning itself, not because you all don't know about robotics, but I want to make clear what sort of robotics we are expecting in this competition. So, robotics has been a very diverse field, and there's multiple domains that's under robotics. So, in the beginning itself, I want to define what the robot is that we'll be talking about in this particular competition, because you see, there's so many definitions. So, and I just want to highlight a few definitions. So, these actually are the standard definitions that we consider when it comes to robotics. This is the ISO definition. So, and then we have the IFR definition, and also a definition given by Carnegie Mellon University. So, one thing that you can see common in all these three definitions is that it's something that is talking about interacting with the physical world, right? So here you can see it can be a reprogrammable manipulator that can be moved in 3 or more axes. The second one also they say it's about movement in 3 or more axes, and in the third one they are telling it's about enacting with the physical change in the world. So the common thing that you can see in all these three definitions is that it can actually interact with the physical world. So right now you probably might see that there are things like RPA, robotics process automation, and PO software solutions. There are people, sort of call them also as robotics. But these pure software solutions do not actually categorize as robotics. We cannot actually consider those as the general robotics that we define here. So when we say robotics in this context, we are talking about something that can interact with the physical world. So this is something that I want to highlight in the very beginning, because you see, this is something some people might get confused later on. They might wonder, we have a software solution. Is this not robotics? Well, under certain definitions, yes, it can be a definition, but in our case, we are actually focusing on this particular definition, right? So the bottom line is that the physical interaction with the environment is a must, right? So it is something that is required to have. So this physical interaction, you might wonder, okay, what exactly is physical interaction? Can't we have a simulation? Well, a simulation is fine, but as long as your robot actually can, has some physical aspect, the environment that you're actually running your robot, whether it's software, whether it's hardware, that's not going to be a problem. As long as it's not your solution, is not your solution. That's what we're talking about. Your solution that we're going to pitch to our competition should have a physical aspect, not entirely software, right? So since our challenge is actually focusing on applied robotics, so our challenge is Sri Lanka Applied Robotics Challenge. So I will briefly tell you exactly what applied robotics is. So it is actually the practical implementation of robotics technologies to solve real-world problems. So you all probably might know what applied mathematics is, applied chemistry is. So these are actually domains where you take existing theories, existing knowledge, existing practices in a particular domain, and you implement them in the real world. Right? You implement these particular technologies or particular theories in the real world to achieve and solve some real world problems. So that's exactly what we're trying to do here. We're trying to take robotics because I know universities develop robotic solutions. Some companies in different isolated silos develop robotic solutions, but they do not actually go and get to real world problems. So our objective is to actually get these robotic solutions and get you all to streamline them to solve real world problems. And it's basically where robotic theory meets practical application. So it's not just about winning a competition, but actually solving a real world problem and using robotics in an impactful way, right? So there's actually 8 focus areas that we'll be talking about in this particular competition. So if your robotic solution is going to fall out of these 8 categories, you can still contact us. So there's actually 2 of us who's taking the lead of this competition. There's me and there's Ramadhu. So you can all the contact details are there. We'll share those in the end of the session as well. So if you check the website, it's all there. So we're actually talking about 8 focus areas, but don't worry if your particular domain is going to fall beyond this. You can still talk with us and see if it's going to fall under robotics. If it does, we can consider it as well. So the first one is healthcare robotics, humanitarian robotics, education and research robots, community service robots, sustainability and climate robots, industrial application robots, precision agriculture robots, and marine resource harvesting robots. So each of these robots addresses a significant social or environmental challenge, as you can already see here. See the humanitarian, healthcare, community service, education, industry, agriculture, or marine. And so you might exactly wonder, how can a robot, serve in healthcare? How can a robot serve as a humanitarian? In a humanitarian aspect, how can they contribute to education? How can they actually contribute to sustainability or climate change? So I will try to talk about each of these sectors individually, and then if you get an exact idea, what are the real world examples are there, and in what context these robots actually come into play in these sectors. Right? Okay. So let's first talk about healthcare. So in healthcare, you can see there's mainly I have actually tabled them, so you can see what sort of types are there in healthcare, what sort of robotics are there in healthcare, and their function. So you can see one of the primary aspects of healthcare robotics is surgical robots. So people perform surgeries using robots now, like the Dayawansa surgical system is there, and then there's rehabilitation robots, which actually assist patients, and then there's caregiving robots, which are actually used to support elderly, and then we have telepresence robots, we have sanitation robots, and we have exoskeletons. So these are like a few areas. So exoskeletons are, a wearable type of robot that actually augments the human capacity. And then these actually what we actually consider as healthcare robots. So, there might be small solutions that we have developed that can be considered as healthcare robots. Might not directly fall under these particular listed areas, but it can be considered. So, if you consider telepresence robots, telepresence where actually you are in a distant area, but the robot's movements can be tracked and observed by you by a particular GUI or a visual tracker. So you probably might be able to develop this type of robot either through a simulation, either through an actual hardware platform, right? And some of these real-world examples of this healthcare robotics, you can see here. We have the Dayawansa surgical system, and we have the Robia Japanese robot, and we have Mabu. It's actually a healthcare conversational AI robot that actually you can converse with. So these are a few examples of healthcare robots. And then we have the humanitarian robots. Here also I have listed down certain robotic entities that actually fall under this category. So we have search and rescue robots, we have disaster response robots, medical assistance robots, diamond detection, post-disaster cleanups, remote communication. So we have multiple types of robots under humanitarian robots as well. So here you can see that these robots are actually doing some assistance during emergencies, during conflicts, during crises, like so, right? So your robot actually doesn't have to, when you're going to actually we'll talk about the comparison stages in the latter stage of this session. So your concept, you can conceptualize certain aspects that actually falls on the humanitarian robotics, and your solution you can implement in a simulation environment, or like a particular hardware or a particular physical setup that we have developed to sort of simulate this, maybe a landmine, maybe a disaster, right? So throughout the competition, we can guide you exactly how to develop this and how to build your robot as well. And once again, here are some of the examples of humanitarian robots. We have the Fukushima nuclear disaster robots. You can see in the left side, they have a robot that actually sent to the Fukushima disaster to actually observe and see if there are any casualties, and if there are any people who are like trapped, like. And then the zipline drones and the Red Cross UAVs are used to deliver stuff, right? Zipline actually delivers vaccines and that, and Red Cross UAVs actually are used for mapping. So they were actually used during the Nepal earthquakes to see exactly what has happened and map the disaster site. And then we have the CRACR robots, which are actually used for search and rescue. And then we have educational robots, which are also used for research. You can see I have put have actually segmented these into two areas: educational robots and research robots. So educational robots, they are speech. They are robots that actually used to teach programming, teach electronics, and to teach robotics concepts in general. And also, these robots can be used to encourage problem solving, and then also make STEM education in so the robot that you see in the left is an Now robot, a very popular robot when it comes to education. You can see it actually has this friendly toy-like shape, which sort of makes it easier for children to interact. And then there's research robots. We have gone a step further when it comes to research robots. They actually developed to test out certain research concepts. Imagine like you want to test out a navigation algorithm. So having to implement a robot from scratch, implement all the hardware, purchase everything, can be costly, can be time consuming, and also can be quite a hustle, right? So because of that, we have already built robots which you can just plug and program and then use it for your application or your research findings, right? So these are some of the education robots that's there: Mindstorms, Lego robots, Vex Robotics, Make Blocks, Vimeo, Bbots. All these things are actually used for educational purposes. They actually are, you can consider those as some sort of toys, but they are developed with the primary objective of making STEM popular, making kids involved in electronics, programming, robotics, and other STEM domains. And research robots, you see we have the Turtlebots, That's in the top. Most of the universities, even in Sri Lanka, have these turtle bugs in their labs because they are a very interactive and a very efficient way of testing out navigation algorithms. As I said, turtle bugs are used to test out complex navigation algorithms like shortest path solving and then SLAM mapping, like so, right? So it's just a modular robot you can just plug and play to program it. Similar with the one that you see in the middle, that's the Pioneer 3DX. It's also used for mapping 3D navigation and all. Also, the bottom one, it's a legged robot. It's the Boston Dynamics Spot robot. It's quite popular robot. You can use it to actually see how the programs and algorithms work for a legged robot, quadruped robot, right? And then we have the community service robots. As you can see, these are the roles that the community service robots play: security, surveillance, monitoring, public awareness, assistive support, health management, sanitation, hygiene, and language information access. So, these robots are actually used for, probably you might have seen, these robots are used for tourism purposes, where you actually send the robots out, and these robots navigate around. They guide the tourists around important tourist attractions. And these robots are actually used for surveillance and monitoring, security purposes. They are used in hotels to interact with the customers who come inside. They are used inside restaurants now. So basically, the idea is these robots are designed to assist, educate, and engage with public, with the general public. So they are typically safe. They are developed in a safe way. They can interact with the public. They can work with normal people. So that's the entire objective of these robots. And so these are the focus areas of these robots: improve public health, safety, and awareness, and then help different level people, and to reduce the burden of human staff. Because if you consider something like a hospital or a hotel, you can always use an additional support by. Sorry. These are some of the community service robots that has actually been there in the world. So we have the Singapore's COVID-19 patrol robot, which was actually Spot robot that was modified. We have cleaning robots. We have sign language robots, and we also have guide robots for visually impaired guys. So once again, what I'm telling is like not for you all to develop robots of this caliber, right? These are high budget robots. It's not very easy for you all to develop these type of robots out of scratch. But you can get an idea of these type of robots. You can get an idea exactly what's going on, what's there, the state of the art in the world, and you can just try to develop something similar in a very scaled down level. And then we have the sustainability and climate robots. So these robots, the idea is actually to contribute to a sustainability in climate change in a positive way, right? So we have been working on some of these projects in Sri Lanka as well, sustainability. We have been deploying drones to measure air quality, measure different pollutants in the air, and we have also been using these robots in agriculture for different purposes, for fertilizer spraying, for plant phenotyping, stuff like that, right? So you can see some of the areas that these climate change robots play. Environmental monitoring is one aspect, pollution control is one. Precision agriculture is something that we'll be discussing separately. It's actually a very broad area. That's actually one of the key areas that we'll be focusing on this conversation as well. Wildlife conservation, reforestation, and renewable energy maintenance. So you can see some of these domains like sustainability, climate robots, as well as agricultural robots. the area is very fuzzy, right? You can't actually say this is going to be climate change, this is going to be agriculture. You can categorize them as both, right? So it doesn't matter. If you feel like you can't categorize this as either of them, that is fine, right? It's good if you are actually if you're actually falling in between two domains. That's actually good because you can your robot actually falling under two main domains. It's totally fine, right? So the objectives of this sustainable and climate change robots are mainly studied here. So to enhance climate data accuracy, to support sustainable agriculture, reduce human exposure to toxic and dangerous environments. This is a real problem for Sri Lankan context. You can actually consider Sri Lankan problems. It's very easy to develop solutions for Sri Lankan problems because they are a challenge. You can see Sri Lankan farmers actually suffering from different health issues, kidney issues because of this, the fertilizer they use and the toxins they have to encounter. So if you can actually identify problem in the Sri Lankan context and try to address that in this comparison, that's actually something that will be really not only good for you, but for the society of the country. So some of these sustainable solutions are here. Once again, these are pretty high-end solutions. We are not expecting you to go and cater the exact level of solutions in this competition. You can definitely have scaled down or simulation-based solutions for this competition's sake, right? So you can see but the left one here is the waste shark. It actually collects floating waste. This is something that actually has a real requirement for the Sri Lankan lakes and all, right? If you look at the Beira Lake in Colombo, you can actually use this type of program. So I will come to the actual objective of this entire competition in the latter stage, because we are not just trying to, just our objective is not just to find some winners of this competition, because it's an open-ended competition. It's open for the undergraduates, it's open for the public, it's open for professionals. Our actual objective is trying to find real solutions and trying to take them to the next level. Maybe commercialize it, maybe to find investors, to find government support. I will talk about this later. Because our competition's objective is not just giving you all award and sending out home. It is actually to get a positive, make a positive impact of your innovation to the society as well as people. So if you can figure out actual existing problems in the country, the scalability of your project is not going to be inside this competition, but it can be used outside this competition. So when you're selecting a problem, that's the first stage of this competition. Try to figure out a problem that actually has that actually can make a huge impact by solving. Right? And then we have the industrial applications robots. This is the most common type of robots that's actually currently there in the country, in the world. But if you feel like you can, make some innovation in this aspect, you can maybe, develop existing manipulator to do, some tasks that it cannot do already. Imagine like you're currently having these robots that is programmed by a teach pendant in a factory setting, but you implement some RA-based solution, right? So I have come up with a problem in one of the dipping companies in Sri Lanka. They actually have these manipulators. They have to be programmed for each task using a teach pendant. I'm not sure that you all know this, but the teach pendant is some like a appliance that is used to jump the robot here and there. But you can program this robot using softwares to actually do this using some intelligence, right? Some AI-based technique. So that is something that you can come up with. So just because these robots are very common and very popular, doesn't mean that there's no area for you to innovate, right? So these are some of the industrial robots that are existing. You can see this is the articulated robot. We call this manipulator, basically. It's just a robo arm. some people. And then we have this Kara robots, right? This is like a configuration type. We have the data robot. These are all industrial robots, right? So these are industrial robots used in industrial context. And then we have the precision agriculture robots. Once again, one of the hot areas in Sri Lankan context, because we are agricultural nation, right? We are agricultural nation, and we can always try to automate stuff. It can help people in multiple ways. It can actually help increase the yield, increase the output of agriculture, right? So you can actually focus these agricultural robots. We have government backing agricultural robotics currently. So if you can figure out a solution in this sector, there's high potential, right? So we have these are a few areas, but once again, these are just example areas. You can always figure out areas beyond this. You can figure out other areas. There are robots used for soil and crop monitoring. We have robots for seeding and planting. We have robots for weeding, spraying. We have robots for harvesting. We have robots for livestock management. And we have robots, basically autonomous tractors and drones for to deliver certain automation tasks. So agricultural robotics, I know, have been developed in universities to certain extent. I know people have been putting these into competitions, putting these into, I as part of this IoT challenge. There were agricultural robots, which are actually there. So they are actually things that are already there, right? So you can actually try these solutions. Once again, these are examples. You can see there are robots that's used for spraying fertilizers. There are robots being, that's used to spray pesticides. There are robots used for weeding, and then these are robots actually used for monitoring large fields and actually monitoring the plant conditions. And then the final one, it's not a very popular area yet, but we are in an island, right? Sri Lanka is an island, so something that we can actually get a huge benefit from. That's marine resource harvesting. So marine resource harvesting is another in-demand field for automation, because humans. Because if you take agriculture, humans can still work on to some extent, right? Farmers are there, right? But if you consider marine resource harvesting, the amount of people who can actually do this thing manually is very limited, because they should be able to dive and all. So it's a domain that robots actually can contribute large. Okay, so these are actually automated underwater or surface robotic systems, which can actually perform tasks underwater, monitor, manage resources in an efficient manner. So why this is a hot area? Well, one thing is the deep sea operations are inaccessible to humans, right? We can't go and just go and do something underwater. So this actually enables this access. And then if you're going to do some action by using marine robots, they can actually reduce the environmental impact by narrowing down it to a certain extent. It can improve the worker safety, because humans going underwater. You probably might remember, like recently there was a submarine that got sunk, right? Because of there are humans inside. If the more autonomous our devices are, we can just completely disregard the human factor. We can remove it and use these robots to perform tasks underwater. And yes, so these are some examples that's already there. Example applications. You can see robots are used for aquaculture, right? So feeding fish, cage inspection, health monitoring, like so. And then these are used for underwater mining and So for C4 excavation, sampling, transport of polymetric nodules and stuff like that. And then these robots are used for seaweed and algae harvesting. And these robots are used for fisheries monitoring. And they are used for coral farming and reef restoration. And also they are used for cleaning. Sea is actually one of the most polluted things in the earth, right? So these robots can actually be used to clean the seabed, right? Once again, these are some examples. Sail drone, is actually what you see here. So why I'm showing these examples is to show you how diverse these sectors are, right? So you might think these are actually very limited domains. No, actually, there's very diverse type of robots that actually you can think of. Just try to divert your mind from the stereotypes that you have when it comes to agriculture, when it comes to marine resource, when it comes to education robots, when it comes to industrial robots as well. There are certain stereotypes in your mind, right? Okay, you picture something when you say marine robots, you picture something like an underwater drone, underwater, rover, right? So it's not the case. Try to divert your mind from these stereotypes. Okay, the typical robots that you see, and think of robots in a novel way, right? With the definitions. That's why I told. And the definitions actually defines for the robotics, and then you can think of problems and develop a solution. Some of the challenges like that, if you are going to consider marine resource harvesting as your challenge problem in this competition, you will have to focus on solving these challenges, which are harsh underwater conditions, limited battery life, complete autonomy that is required to go under unstructured marine. Because you see, we are not talking about plain water. It's going to go underwater to a particular unstructured environment. So you should be able to map the environment, it should be navigate the environment, like so. And high cost is problem, but in your case, you can use a simulation, of course, to avoid the cost. And when you're extracting resources from underwater, you always have to think about ecological sustainability, and you should not disrupt that by just resource extraction without any control. So all these things you have to consider when developing robots. Now we talk about the completion stages, as you all already probably might know, and probably might not know. Anyway, there's 3 stages. So the first stage is the problem identification. In this stage, you are not supposed to think of a robotic solution. You are not supposed to present a robotic solution. Of course, when you say identifying a problem, you should have a solution, at least a draft solution on mind, right? Just because imagine like you have a problem like war. War is a problem. It's a global problem. Well, you can just say, okay, common problem in the world is global war, but you should also have a solution in mind, because in the second and third stage you will have to present the solution and finally implement the solution. So whenever you are coming up with a problem, think of the solution also beforehand. But what we're expecting in the first stage is only the problem, right? And the problem you have to submit using a short video and a presentation. That means maybe 3 or 4 slides support your support your claim. So maybe you can do the same presentation, make a video of it, record it, and submit the presentation separately. So you can see it's a very simple thing. The first stage, you have to identify a problem, right? A real world problem. I will show some problems and examples as well for you to get an idea. The next round, you are supposed to present something to us. It can be an online presentation, your conceptual solution, plus a demo. So this demo can be, a basic simulation. It can be a CAD drawing. It can be a conceptual drawing, right? It doesn't have to be a very sophisticated solution, but we expect to have at least 40% of task completion by the time that you come to the intermediate round. When I say task completion, I mean not actual physical fabrication or actual simulation development, but we should be able to see, okay, you have identified this solution to at least this extent, a certain extent. And we should be able to see that your solution is actually feasible, right? The intermediate round. And the final round, you have to showcase the full robot. Once again, the full robot can be a hardware or realistic simulator. So I'll talk about each of these stages next. So let's first talk about the problem identification stage. Here you have to identify a problem. Example, the dairy lake stinks. The problem because of certain pollutants, certain biochemical activities that's happening because of the pollutants. That's a problem, right? It's a real problem if you're going, going past Colombo, going past the Dairy Lake, maybe the Navamad area, Gangaram area. That's actually very hard to go by foot because it's stinky, right? That's a problem, right? A problem for people who are going to work in that area. There's a problem for people, the residents who are staying in that area. Problem for the tourists who are coming to that area. Gangaram site that it's actually a landmark site. So it is actually a problem. So is that a valid problem? Yes. If you come up with with 3 or 4 slides saying that, okay, the pollution in the Gangaram area, the Bear Lake, is a problem. Yes, we understand that. We accept that. You can say, there's this. What else? You can say people dying because of accidents is a problem. Yes. You're looking at a robotic solution for that. Yeah, if you can, by all means, yes, that's a proper solution to a valid problem, right? So first, identify the problem, right? So try to identify the problem by observing global and local issues that's there in the world. You can look into the community needs. You can look into the industry needs. You can talk to people. You can do a survey. Go to the industry. If you're already working in a company, you can do an internship. You can see around, look around, and see what sort of solution that your company or industry might need, and you can figure out a solution for that problem. And you can use techniques like design thinking and empathy mapping. So we will do actually in this competition, we will actually have multiple support sessions depending on the requirement of the registrants. So if you all need help in the first stage, we can definitely do that. If you all need support in the second stage, we can definitely do that. Finally, in developing the robot, if you all need help, you can do that. We have the expertise within IEEE and within because IEEE Sri Lanka has a huge community of experts, and we also have a lot of universities partner with us. We have student chapters, so we can support you all with these solutions. We can perform. We can actually conduct workshops for you all to actually get a proper understanding of these areas, these things. So first thing is identify the problem, right? So after the session, you probably might, have it clear how to identify the problems. I'll try to make it clear what these problems are. Next thing is you have to identify the solution, right? So once you have the problem, you have to think of the solution. So you have to figure out exactly what you want to accomplish in the end, right? Eventually, what's your end game, and what are your requirements, and whether there are any limitations. Imagine like you are going to develop some solution. Okay, yeah, let's take the Bear Lake example once again. It's stinky. There are pollutants. You want to clean it. So what you want to accomplish is actually a clean, at least a partially clean Bear Lake. The requirements. Well, you need a hardware solution that actually can perform this task. Maybe certain. You have to technically evaluate some filters. You have to have some mobile, surface moving rover sort of thing, like an ROV. And then you have to figure out what the limitations are. Well, one of the key limitations is going to be be the money, right? The budget, and there might be certain limitations from the government restrictions. You can't do these things, right? You can't use these. You can't have produce this much of noise. You can't deploy this type of drone, right? Public area. So we'll have to figure out the limitations. Power is going to be a limitation. You are supposed to carry certain amount of battery. And then you have to figure out who's your customer. If you are developing a product. So as I mentioned earlier, this competition is not just focusing on developing something and winning a competition. Our overall objective is providing something for the community as well as for you. So if you provide a solution to existing problem, one thing is don't paste a solution just by winning the competition or taking part in the competition. You have to always think about the commercial potential of your product. So if I could think of the commercial potential of the product, you have to think of the customer who's going to use it, who's going to benefit from the product, who's going to be the end user. In case of the data lake problem, the end user can be the government. Because if that actually works, it actually will have some benefit in the tourism. It will be having a benefit to city beautification, right? It will have impact on the residents' quality of life. So the end user is going to be the population of the country, and the tourists who will be visiting the country, and who will be catering to that. It will be the government, right? So that is something that everything. So the next thing is how to actually identify the solution, right? Because there can be multiple ways that you can come up with a solution, but how to exactly identify the solution is something that you have to think. So I have listed certain things that you can do. So you can do brainstorming, you can form a group, you can talk among yourselves, you can figure out solutions among yourselves and try to identify solutions. And then you can actually sketch your solution in a conceptual way, right? And also you can develop your logic and all these things, and you can also think about the feasibility and the simplicity. And also another thing, you have to think about the feasibility, the cost, because once again, our objective is to somehow get your product into the market. You should be able to somehow commercialize your product into the market, right? So that's another thing that we want to focus. And here we have some problems, and we have some solutions. So one problem here, this is actually, I want to actually show you what the problems are and how to develop a solution for that. On the left, you have problem. So you can see elderly patients in remote areas face limited access to physical therapy and rehabilitation services. This is actually a problem in Sri Lanka. There are elderly patients, elderly people who actually have no access, almost zero access to physical therapy and rehabilitation. Of course, if you consider people in the Colombo area, they might be having this access, but if you consider people in the remote areas, they probably might not, right? So you can actually think of developing an autonomous rehabilitation robot for this. The problem is this, the solution is this. How are you going to develop this? Well, for that, you have to think innovatively, you have to do some research. And the development should not actually be a physical solution, it can be a simulation, right? Because this type of a demonstration can be quite costly. So we can have a simulation also that can be taken as a valid submission. Another problem is natural disasters often result in delayed rescue efforts due to hazardous environments. So we can actually develop a search and rescue robot. This can be a legged robot that can perform a search and rescue task. This can be a robot that has been catered to the Sri Lankan environment, Sri Lankan ecosystem. This can be a robot that is actually a drone or a UAV, right? The drone can be a fixed-wing aircraft, it can be a quadcopter, it can be a multicopter. So you can develop these solutions. Once again, you have the full authority and the full liberty to come up with a solution. We are not dictating how your solution is going to be. Right? We are not putting restrictions and saying, okay, this has to be a drone, this has to be a fixed wing aircraft, this has to be a robot on the ground. No such thing. It's open-ended. As long as your solution is good, that's all. So one thing, once again, I want to highlight this. I'm reiterating this because this competition is going to be, as long as your products are good, there's not going to be any losers of this competition, because we are trying to get you out to a market that's existing globally, where you can pitch a product, where you can pitch a robot solution and actually get some funding, or maybe get some investment, and you can maybe probably go for your own startup. And you can see many schools lack hands-on tools to teach robotics and STEM effectively. So you can actually develop a low-cost robot kit, right? That's an education robot solution, right? You can see how diverse these are, right? How diverse all these solutions are. They are not. So you probably might have been part of different robotics competitions, but our competition's objective is not just doing some task. We're actually focusing on solving real problems and trying to get your robotic solution to a competitive market, right? So you can see, if you look at all these solutions, the first one was actually an exoskeleton, the second was a drone, the third one is actually a robotic kit. So your robotic solution can be diverse. There's no hard and fast rule that says, okay, this is the only robotic solution it has to be, right? It can be a simulation, it can be a hardware development, it can be a robotic kit, it can be a UAV, it can be exoskeleton, it can be a wearable. All are valid in our competition. And the next thing is, assistive robotics, where, you can develop some sort of like a assistive robot to actually help the visually impaired, or maybe guide robot, or some robot that actually guides people or navigates people inside the hotel environment, or in a hospital, in the public, in tourist attraction. This type of robot is also something that you can think of, right? And then you can develop a robot to monitor. So once again, the left-hand side is the problem. This is what you will submit to your. This is the thing that you will submit to the first stage. Problem. Identify a problem. Submit that to the first stage. Problem is valid, and if you feel like the problem can be solved using a robotic solution, you can go to the first stage. The second stage, you will come with a solution like this, right? With a small video clip on a presentation. In the final stage, it's only where you will have to develop the solution, right? So in this case, you are telling, okay, monitoring pollution in rivers is a problem, right? It's happening infrequently because of certain conditions, and that actually develops delayed environmental responses, right? Basically, the idea is you can't frequently monitor the conditions in the rivers. Solution: develop autonomous aquatic robot, right? Maybe a surface level robot. So this robot maybe does some routine checking in the lakes, in the rivers. Gives you the feedback using an IoT mechanism to a small app. Who's the end user? Can be the government, can be a private entity, right? Because there are enough investors who are actually looking at these type of solutions. And you can see small and medium scale. SMEs, most of the companies in Sri Lanka that actually has industrial robots employed are large scale companies, right? But you can talk to SMEs, small and medium enterprises, and figure out their problems. They might be actually willing to go for a robotic solution, but they might not be willing to do the investment. For those guys, because when you say industrial robot, most people think it's an articulated 6 degree of freedom robot. But you can actually develop custom robots, right, for their own requirement using your skills for a very low cost, right? So you can think of ways to actually come up with solutions for real world problems, real Sri Lankan problems in the industry, develop robot solutions. And this is agriculture problem. Once again, I'm telling Sri Lankan government currently is focusing on mainly 4 areas. That's tourism, agriculture, marine resource harvesting, and manufacturing. So agriculture is something that is one area that's going to always be a hot topic because people will never stop eating, right? So if you can develop the agricultural robotic solution, it will be really valuable for the society, for the community, and for you, because there's a high commercial aspect, high commercialization aspect for agricultural solutions. So, and also CV. This is actually in the context of marine harvesting, marine resource harvesting. So you can see once you come up with the problem and you develop the solution, you can go for the implementation. So implementation, as I said, can be twofold. You can either decide to go for a physical implementation or you can go for a simulation implementation, right? So imagine like you are developing a solution for space environments, right? So, I mean, you can't develop a hardware, right? So in that case, you will have to go for a simulation. You probably might have to develop some simulation if you're going to go for an underwater task. But then again, if you're going to develop something like a wheelchair, autonomous wheelchair for someone who's impaired neck down, you can go for a physical implementation, right? You can go for a scaled down. You don't have to have actual wheelchair. You can have a scaled down small model that actually has sensors and all these things in, plugged in. If you're going to develop something like, a drone for agricultural modeling, you can go for an actual. If you have a drone, you can develop that, right? So just plug in some sensors and make some interconnections with some some dashboard, interface it, and you will get all the readings. So once again, you can decide how to do it, and we can based on your requirement. Once again, we can actually schedule some support sessions for the physical implementation, maybe for the software implementation, because you probably might be requiring certain tools, right? Like MATLAB, Gazebo, ROS, Operasim, Rebot. So depending on what you're going to use, you're going to use hardware, you probably might need some help with programming hardware, programming microcontrollers, programming Arduino boards, programming different architectures other than Arduino, like Raspberry Pi and STM32. So we can offer that help. We can offer some help with those things if you want how to deploy AI algorithms, in a small microcontroller. Like if you consider about edge computing or something like that, you can help with that as well, right? So depending on your requirement, you can schedule support sessions. So these are a few tools that you might require. You can look into. If you're going to go with hardware solutions, you will think about multiple microcontrollers, Arduino, Raspberry Pis, STM32s, actuators of different types like servo motors, DC motors, stepper motors, etc. Different sensors and different manufacturing techniques like 3D printing and all. And simulation platforms, you will think about certain simulation platforms like ROS, Gazebo, Pbots, VREF, Simulink, basically MATLAB, and like URD file generation, SDF file for robot modeling, and then RVIS is a ROS visualization tool, more for motion planning, and once again ROS. Don't worry about these things based on a requirement. You see, you don't have to learn everything. When you're trying to solve a problem, you only have to figure out what the problem is. Then you have to come up with a solution, and then to achieve the solution, there are certain tools that you can use. Now, do you learn all the things that's existing in the world, right? You just have to identify the problem that you're trying to cater. Identify the problems that's existing in that particular area. Identify the solution for your problem. Then figure out how to actually implement the problem. And to implement the problem, there are certain tools that you can use. And then you can figure out how to implement these tools, implement these solutions using these tools. You don't have to learn all the tools to implement solution, right? But one or two will be sufficient. Right? And what not to do? We are not recommending for you all to use off-the-shelf robots unless your solution is very novel. Right? Imagine like you are developing some sort of like a very novel AI algorithm, your drone for plant observation. Then of course using an off-the-shelf drone is fine. But if you are just going to make existing drone autonomous, that's basically not very much competitive, right? And don't submit when your submission actually is this documentation comes in terms of the first case, the first submission where you have to submit the presentation. It can be 3 or 4 slides. Can be very concise, very short, as long as you can highlight your problem clear, right? We don't need bulky submissions. You don't have to go with a very poor documentation. Just have a very simple, very compact idea of your problem is sufficient. And also make sure that your problems are feasible in the real world, not unrealistic stuff. And you can actually these are some tips for you to actually succeed in your competition. Your problem needs to have some innovation and some impact, right? So basically, your problem has to have some impact to the real world. You should be able to do something in the real world, so we can actually commercialize it or maybe go for something beyond the competition. And you can be creative in your demos. You can try different techniques. Try to test early so that you are not stuck in the last moment. You will come up with last moment hiccups or last moment surprises with your hardware or simulation. You try those beforehand. And focus on the problem that you're trying to solve, right? Focus on the problem that you're trying to solve, because don't try to divert from the problem that you're trying to solve, right? Just focus on it. So why participate? As I mentioned, this competition is not just focusing on winning and giving you all a prize. Of course, we'll be giving a prize. I will disclose them in due time. But we are actually focusing on taking a product beyond this competition to commercialize it. We have a very good support network in IEEE, beyond IEEE. So if you consider, we will get you the chance to participate in the World Robotics Meetup, which actually is organized in partnership with the Sri Lankan government. So it's actually organized by the Imperial College London, which is actually a world's number 2 ranked university. Currently number 8 in Times Higher Education, number 2 in US rankings. So anyway, within the top 10. So yeah, we are partnering up with the World Robotics Meetup. I am actually the local coach of the meetup. It's done in partnership with the Sri Lankan government, actually handled by the NIRDC, is under the President's Secretariat, as well as the Imperial College London. So you will get the chance to take part in this competition. Not a competition, it's an event where you will actually get the chance to meet UK-based venture capitalists, UK-based academics, government officials of Sri Lanka, government officials of the UK. So the event is basically focusing on streamlining robot solutions to investors, to academics, and basically opening up the Sri Lankan market to the world robotics market. So you will actually get the chance to pitch your idea, guys who are over there, and we will actually support you in sending your solution to global robotics challenges, and also we will get to network experts in the domain, in the industry as well as in academia, right? So once again, we are making this open-ended problem, open-ended competition, open to everyone, not only undergraduates, not only for school children. It's open for professionals. It's open for graduate students. It's open for basically general public to take part, to develop, to identify an existing real-world problem in the country or in the world, to come up with a solution, a robotic solution, and actually implement that, and they are ready to take your product to the next level. It's basically like a Shark Tank, but in robotics context. So this is the Gold Robotics Meetup, as I mentioned. It's organized by the Imperial College London in partnership with some Sri Lankan entities. So once again, if you need any information about this, you can contact me because I'll be able as the local co-chair for this. And we are doing this in partnership with the government of Sri Lanka. So, and a final note, this is going to be something that is beyond your normal robotics competition. It's going to be something actually bigger than all the competitions, because the idea is to cater existing real problems, find solutions, and to actually have an impact not only for the community but also for your career in robotics or in technology. So definitely register. So maybe you might decide later on to opt out. That is fine, because you can still register, because you are planning to help some support sessions, to help some to organize some support sessions on basic robotics, maybe on ROS, maybe on some hardware development, so that you all have the background and the prerequisites to compete in not only this challenge but in other challenges. So with that, I will actually end my presentation, but I'm open for questions. And I think Ramudu has shared the link. So me and Ramudu, we both are here. So if you have any questions on the competition, on the challenges, on what is expected from your end, on what to submit, or anything basically, you can ask us. So you can drop a text in the chat. Recording, I think I recorded this presentation. I can provide that. Maybe you can contact me. Share my contact. I will share the recording. Yeah, yes, I will. We can share the contact. We will share the recording. Any other contacts that any other questions that you all have to ask, you can ask. No, there's no written exam. If I once again explain what we are expecting in the stages, the first submission is going to be your problem, right? You'll have to identify a problem, a real world problem, and you will have to I think, right? You have to identify a problem. It can be so these problems I mentioned here, right? It can be some problem that can be solved using a robotic solution. So I have some examples here. You can find a similar problem in a particular area that you are interested in. So it has to fall in these areas. We are talking about 8 main areas, but once again, you are free to go beyond this. But in healthcare, humanitarian sector, education, research, community service, sustainability, industrial applications, agriculture, and marine resource harvesting, these are the main key areas that we're focusing. So if you can find a solution to a problem existing in these areas, using robotics, you have to first submit the problem. We have to submit a small video along with some few slides. That's sufficient for the first stage. Second stage, you will have a small presentation with some of our judges, and we will evaluate your solution. There also, it's a presentation. That's it. Small concept, design concept, simulation or something. In the final round, you will have to demonstrate the final robot. But this once again doesn't have to actually be a physical robot. It can be a simulation as well, depending on a problem. If the problem is very simple, then a simulation might not be sufficient. But if your problem is, large scale, simulation is also. But we encourage you all to have practical, hardware development. Because the idea is, once again, we don't want to stop you all with our objective of this competition is not just to give you all some price and send you all off. We want to get you all to commercialize the product, get you all to the market, and actually have some. So it's always good to get. It's always possible for you all to get proper investments, proper, support from the community if you all have some tangible product. That's the usual practice in the market. They prefer some working model. I hope I answered your question. That's another one. We will be able to make mind. Yeah, of course. So in the first stage, anyway, you are also going to submit the problem, right? As long as you are trying to, so the problem, I'm not sure that you are trying to ask whether you can change the problem later. Or design, of course you can. Design, of course you can. But if you're going to change the problem, that means stage one, you submit a different particular problems. Later on, you submit another problem. Well, that is something that we'll have to discuss internally. As long as your problem is justifying, our earlier factors, we can love it. But design changes, of course, yes, you can change. Because in the end, what we'll be looking at is your solution. As long as your design can address the proposed problem, we can go ahead. Any problem? Any other issue? So once again, we encourage you to register, and because we are trying to develop a community anyway, right? So try to compete in this. Don't try to think in a very high level, because as we gradually go on, you can basically get an idea what's going on. We'll try to have certain support sessions for you guys so that you will see what exactly is going on. You learn something out of this, hopefully. But we'll be questioning you all, like, what sort of things that you all require. We'll not be blindly organizing sessions, because I know that there are certain requirements that you all probably might have. So that means that we might probably be able to give you all. So I think you can do. Me and Abdu will be in contact with you all. So depending on what exactly your requirements are, we can organize support sessions targeting the competition. But for the first stage, of course, I think it's not going to be very hard, right? Just have to figure out a problem that you can come up with a solution. Why we came up with this particular plan is so that the entire engineering design process is covered. So we have you're trying to figure out the problem, and you're trying to identify a solution. So by that way, you can actually see can see this. So the entire engineering design content is covered. Right. So it will be an engineering design exercise for you, as well as a robotics challenge. Because I think we don't usually test the engineering design aspect of students. So actually, we want to address both these. Right? Yeah, we want to address both the engineering design aspects of students, as well as the robotics aspect. Right? So we try to cover both these areas. So stick to these robotics domains when you're figuring out the problems, so that you don't deviate very much from right. Any other questions? There's no questions. We can, I think, wind up the session. Okay, there's another one. 28th is no. 28th is just the registration. You register by 28th. Rahul, when is the next deadline for the first stage? First submission? I think Ramudu, I can check with Ramudu and tell you exactly the dates.
Yeah, sorry. So the first registration deadline is on 28th.
Yeah.
So yeah, 28th is registration deadline. After that, until June 20th, you all have time to have time to prepare for the preliminary rounds, like the first stage. After, if you pass the first stage, we will let you know by June 27th whether you are good to go for the second stage. So on the second stage, which will be a live demonstration where there will be a few judges as well, will happen on July 20th. And if you all pass that stage as well, we will be having a finalist announcement on July 27th. And then depending on how you guys ask for any workshops or things like that, we have a current one planned to do the current workshop to be done on 9th of August. But depending on how you guys ask us, we can organize more than one workshop for you guys. And finally, there will be a final demonstration on the 6th of September. This will be a physical session, physical event where you guys will have to bring your robots and everything and present it in front of everyone. Yeah.
So I think the dates are clear, right? So you all have enough time, I guess. So
yeah, everything is
yes.
Yeah, all the dates are there in the guideline booklet, which you guys can find in the when you are registered through the forms.
Yeah, so in that case, I think the dates are very clear. So that's what I'm telling you. I encourage you all to register. So because we have kept enough caps for you all to do all the work. So 20th is just registration. So register. You're not going to lose anything by registering, right? You can always do that opt out later. So register first, and then the first stage one is basically a very easy stage. Just a video, small short video, and a presentation on the problem. And September is where you'll have to actually develop the product. So there's maybe like 3 months. That's enough to develop a very comprehensive product. Another question, I guess. So we have a solution that is a network of wearable devices instead of. Yeah, because so when I said the robot doesn't have to be a moving device, because what I actually said was there should be physical interaction. With our robot definition, it says actually the robot has to have some physical interaction. You consider a wearable or exoskeleton or prosthetic, they are actually worn by a person. So the physical interaction is happening between the person's arm or the person's body as well as the environment. So definitely it's going to be there's going to be a physical interaction. So what I'm actually saying, what I said that it is not defined as robotics is there are certain software tools like pure vision-based solutions where you have the vision algorithm in the computer, the camera, that's it. So there's no physical interaction. Some RPA tool. Mostly this is for RPA tools. There are this thing called robotics process automation. You probably might have heard of robotics process automation, automated, data gathering, automated, documentation, automated. That's basically what I mentioned as RPA. You can just Google and see. It is not robotics. And you have pure software solutions like algorithm optimization, chatbots, LLMs, they are not considered as robotics. They are AI, but they are not considered as a robotic solution. For it to be a robot, there should be a physical interaction. So wearables, exoskeletons, prosthetics, all these are considered as robotics. So they actually fall under healthcare robots. So I think I have mentioned here exoskeletons. I have not mentioned the prosthetics, bionics here, but those are also part of it. So yes, definitely, by all means, go ahead. Wearables are totally fine. Any other question? So if you all have questions beyond this, what you all want to talk to us, yeah, you can contact us later. We are available in WhatsApp. So I think all the registrations will be uploaded to a WhatsApp group. And if you all want to have a meeting later on as well, if you all want to maybe have a discussion later with us to clear out doubts, we can definitely maybe schedule meetings once every 2 weeks or so. So you can talk to us. So you may request us, request me or Amru. So we can definitely schedule meetings and talk with you all to clear any doubts you all have. Okay. All right, guys. We hope that you will register, all of you. Maybe tell your friends. I know that there are people who are developing these type of products for their final year projects, for their university projects, for their company projects, as hobby projects, for passion, right? So you can just try out this and see. So you might be, you might not be, but still the experience and the opportunities that might arise from this might be very large. So just try and see. Even though if you don't have a complete product by September, still there might be chances that you can still approach people, find certain stuff. We have enough experiences about this. As such, I can share those as we move along in the future. We'll see how things go. All right. And thanks everyone for taking part. If there's nothing, Ramdu, we can wind up, right?
Yeah. If there are no other questions, we can wind up the session.
All right, guys. Thanks for taking part and have a good week. Good night.
Yeah. Bye, guys. Good night.